Bohr's model of an atom. Before seeing Bohr's model, let us see what is Rutherford model. Rutherford explained the nucleus of the atom. He said the nucleus of the atom contains positively charged. The nucleus is a positively charged. And the electrons, negatively charged electrons, revolve around the nucleus in circular orbits. But he has not explained anything about the electrons in his concepts. Now let us see Bohr's model. Niels Bohr has explained very well about the electrons. According to Bohr's model of an atom, the negatively charged electrons revolve around the positively charged nucleus in definite paths called orbits or shells. So the negatively charged electrons revolve around the positively charged nucleus in definite paths called orbits or shells. The energies of electrons in an atom are quantized. That is, the energy of the electrons revolving in the orbit will have, the electrons revolving in circular orbits will have definite energy. That is, the energies of the electrons are quantized, you will see. Electron can revolve only in those orbits in which the angular momentum of the electron must be equal to an integral multiple of h by 2 pi. That is, mvr is equal to nh by 2 pi, where m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit, is equal to n into h by 2 pi. H is the Planck's constant. So, electron can revolve only in those orbits. The electrons can revolve only in certain orbits in which the angular momentum of the electron must be equal to an integral multiple of h by 2 pi. Therefore, this is the angular momentum, mvr, mass of the electron into velocity of the electron into radius of the electron is equal to nh by 2 pi. mvr is the angular momentum. So, angular momentum is equal to nh by 2 pi according to Bohr's model. So, here the energies of the electrons in an atom are quantized. That means the electron in a particular orbit will have a particular energy. Right. So, here mvr equal to nh by 2 pi, n is equal to 1, 2, 3, 4, etc. Here you will see this is the nucleus of the atom inside, positive charged nucleus, around which the first shell is the K shell, innermost shell, where n is equal to 1. The next shell is the L shell. This is the L shell. The electrons revolve in K shell. The electrons can revolve in L shell, and the electrons can revolve in M shell, and the electrons can revolve in N shell, and so on. So, in K shell, n is equal to 1. In L shell, n is equal to 2. In M shell, n is equal to 3. And in N shell, n is equal to 4. The innermost shell is the K shell here. Outermost shell is the N shell here. The energy of the electron is highest here in the N shell and lowest in the K shell. Therefore, the energies of the electrons in an atom are quantized. That means the electron will have a particular energy in a particular shell. So, in each and every shell, the electron will have different energies, different energy levels. These are all called energy levels of electrons. This is the higher energy level, and this is the K shell is the lowest energy level. N shell is the highest energy level here. Therefore, these are all called, the energies of these shells are called different energy levels. The electrons will have different energies in different shells. When the electron jumps from the higher shell to the lower shell, that is the outermost shell, to the next innermost shell, the from the outermost shell to the next inner shell, next inner shell, it will lose its energy in terms of radiation. It will lose its energy, it will emit radiation and lose its energy when it jumps from the outer shell to the next inner shell. Similarly, when the electron jumps from this shell to the next inner shell, it will emit radiation and it will lose its energy and occupy the next shell. So like that. Therefore, the difference in energy we can write like this. For example, if the electron, for example, let us see, if the electron jumps from L shell to K shell, L shell to K shell, we can write E2 minus E1 equal to H nu. E2 minus E1 is equal to H nu. E2 minus E1, this is E1, this is E2. E2 minus E1 equal to H nu, where E2 is the energy of the electron when it is in the L shell. E1 is the energy of the electron when it is in the K shell. So when the electron jumps from L shell to K shell, the energy lost, it will emit radiation. It will emit radiation, that is, it will lose its energy in terms of by means of radiation. Therefore, E2 minus E1 equal to H nu, where H is the Planck's constant, nu is the, where H is the Planck's constant, nu is the frequency of radiation, frequency of emission, frequency of radiation, right? So this is the postulates of Bohr's model, right? Then limitations of Bohr's model. What are the limitations? It could not explain the Zeeman effect. Bohr's model could not explain the Zeeman effect, that is the effect of magnetic field on the the effect of magnetic field on the spectra, and it could not explain the Stark effect, that is the effect of electric field on the atomic spectra, right? These are all the two limitations of Bohr's model. Therefore, the limitations are, it could not explain the Zeeman effect, that is the effect of magnetic field on the atomic spectra. Second one, it could not explain the Stark effect, that is the effect of electric field on the atomic spectra. So this is according to Bohr's model. This is applied in hydrogen atom. So now let us enumerate Bohr's model of atom. The negatively charged electrons revolve around the positively charged nucleus in definite paths called orbits or shells. We have seen. This is the nucleus, is the positively charged nucleus, and the electrons revolve around the nucleus in circular orbits called shells. The energies of electrons in an atom are quantized. That is, the electrons will have different energies at different orbits. Then electron can revolve only in those orbits in which the angular momentum of the electron must be equal to an integral multiple of h by 2 pi. That is, this is the angular momentum, where m is the mass, v is the velocity, r is the radius of the electron. Therefore, angular momentum of the electron is equal to nh by 2 pi. Angular momentum is the integral multiple of h by 2 pi. N can be 1, 2, 3, 4. When n is equal to 1, it is K shell. When n is equal to 2, it is L shell. When n equal to 3, it is M shell. When n equal to 4, it is N shell. Like that. So these are the postulates of Bohr's model.